This equation is only true when x is equals to 0 or 7 minus x is equals to 0. So what we need to say here is that x is equals to 0 or 7 minus x is equals to 0. And then if 7 minus x is equals to 0, then x is equals to 7. This is the answer to 1.1.1. That's all we are supposed to do. And 1.1.2, on the other hand, we have a quadratic equation, 3x squared minus 2x minus 6 is equals to 0. We're supposed to find the value of x correct to 2 decimal places. So as soon as we see correct to 2 decimal places, we know we're going to use the quadratic formula. So that is x is equals to minus b, which is minus 2, plus or minus the square root of b squared. So we have minus 2 squared minus 4ac. The value of a is 3 and the value of c is minus 6. And we are dividing everything by 2a, which happens to be 3. So if you put that in your calculator, you're going to get x is equals to minus 1.12 or x is equals to 1.79. That is the values of x correct to 2 decimal places. 1.1.3 is quite an interesting one. We have 3 minus x multiplied by x plus 7 being less than 0. This inequality is already factorized, so we don't have to do much here. We can go straight to the critical values. We can say that 3 minus x is equals to 0 or x plus 7 is equals to 0. And then here we're going to have minus x being equals to minus 3, so x is equals to 3. And on the other side, we're going to have x being equals to minus 7. And just like that, we have our critical values, 3 and minus 7. So let's see if x lies between 3 and minus 7. If it doesn't lie between 3 and minus 7, then it will lie outside. So how do we then test if it lies between minus 7 and 3? We take a number that is between minus 7 and 3 and substitute it in our inequality. If our inequality holds, then we know that our solutions lie in that range. So between minus 7 and 3, let's take 0. So we're substituting it here. We're going to have 3 multiplied by 7 being less than 0. So 21 is not less than 0. So we can see that our solution is not between minus 7 and 3. So it must be outside that range. What do I mean by that? X needs to be greater than 3 or x needs to be less than minus 7. For these values of x, our equation, our inequality is going to hold. Let's move to 1.1.4. We have the cube root of 32 being equals to 8 to the power 3x multiplied by 2 to the power 6x. So when you have an equation like this, the first thing you should be looking at is writing all the numbers with the same base. We have 2, 8, and 32. If we want to write those numbers with the same base, then the number to go for is 2. Let me show you how. Here we're going to have 3 and then the root of 2 to the power 5. 32 is just 2 to the power 5. Being equals 2, instead of 8, we're going to have 2 to the power 3 multiplied by 2 to the power 6x. So on the left hand side, we're going to have 2 to the power 5 divided by 3 being equals to 2 to the power 3 multiplied by 3x, that is 9x, multiplied by 2 to the power 6x. So 2 to the power 5 divided by 3 is equals to 2. Same basis, we can just add the exponents, 15x. So obviously we're going to drop the bases and equate the exponents. 5 divided by 3 is equals to 15x. So x will be equals to 5 divided by 3 divided by 15. So the value of x here in 1.1.4 is 1 divided by 9. And just like that, we have the answer to 1.1.4. 1.1.5, let's take a look at this one. We have x minus 4 minus 2 square root of x minus 1 being equals to 0. Let's take these to the right hand side. We're going to have x minus 4 being equals to 2 square root of x minus 1. And then because we have this square root, it's better we square both sides. So on the left hand side, we're going to have x minus 4 squared. And then on the right hand side, we're going to have 4 multiplied by x minus 1. And then let's solve the left hand side. That will give us 8 squared minus 8x plus 16 being equals to 4x minus 4. So x squared minus 8x minus 4x, that is minus 12x, and then 16 plus 4, that is plus 20 being equals to 0. Factors of 20 that when we add we get minus 12, that is minus 10 and minus 2. So we're going to have x minus 10 multiplied by x minus 2 being equals to 0. It should be easy to see now that x can be equals to 10 or x can be equals to 2. But we need to check here whether all this solution holds. Why am I saying that? We had a square root initially here, and then we squared both sides. So that introduces solutions that might not be necessarily true on the original equation. If we substitute 10, we're going to have 10 minus 4 minus 2 square root of 10 minus 1. So that is 9. So this is 10 minus 4, which is 6, and then minus 2 multiplied by 3. This is equals to 0. So 10 holds. Let's see if 2 is also going to hold. If we substitute 2, we're going to have 2 minus 4 minus 2 multiplied by 2 minus 1. So that's the square root of 1. So we have 2 minus 4, that is minus 2, and then minus 2, which is not equals to 0. So 2 is not a solution to this equation. Yeah, we need to be aware of that when we square both sides. We introduce solutions that might not necessarily be true. Let's move to 1.2. We're supposed to solve for the following equations simultaneously. The first equation, we have x, so that is 1.2. We have x minus 2y being equals to 1. So x is equals to 1 plus 2y. I can call this equation 1. Why am I writing x in terms of y? Because if I write y in terms of x, then I'm going to divide by 2, which will get messy. So it's better I just make x the subject of the formula. And then the other equation, we have x squared minus xy plus 2y squared being equals to 2. So I'm going to substitute. I can call this equation 2 and say that I'm substituting equation 1 into equation 2. So that will look like the following. In place of x squared, I have 1 plus 2y squared minus, in place of x, 1 plus 2y multiplied by y plus 2y squared being equals to 2. So what is 1 plus 2y squared? That will give you 1 plus 4y plus 4y squared, and then minus y minus 2y squared plus 2y squared minus 2 being equals to 0. So I have 4y minus y. That is 3y. And then minus y squared plus 2y squared. That is 0. So here I'm going to have 4y squared plus 3y. 1 minus 2. So that is minus 1 being equals to 0. So that is what I need to factorize. If I do that, I'm going to have 4y. And then here I have y. And then we're going to have 4y minus 1, y plus 1 being equals to 0. So it is easy to see here that y is equals to 1 divided by 4, or y is equals to minus 1. What is the value of x when y is equals to 1 divided by 4? X is going to be equals to 1 plus 2 multiplied by 1 divided by 4. So x here is equals to 3 divided by 2. On the other hand, x will be equals to 1 plus 2 multiplied by minus 1. So x is equals to minus 1. That is the answer to 1.2. Let's do 1.3 in a separate video. It will cost 3,500 for X number of friends to go on a trip. 4 friends do not have money to pay. The remaining friends have to pay an extra 43 rand 75 cents each to cover the cost of the taxi. And 1.3.1, let's calculate X, the number of friends who want to go on the trip. Let's make sense of our situation. When we have X number of friends, they pay 3,500. And when 4 friends don't have money to pay, then the friends that are remaining, the remaining friends agree to pay an extra 43 rand 75 cents. Let's look at how much each person pays when we have X friends that are going on the trip. So here the cost per person will be equals to 3,500 divided by X. The total amount paid divided by the total number of people. But 4 friends decide not to pay. So now instead of having X number of friends, we have X minus 4. So the cost per person when we have X minus 4 will be 3,500 divided by X minus 4. Now the friends are paying slightly more because the 4 friends do not have money to pay. We can say that initially the X friends were paying Y amount of money. And then when the 4 friends don't have money to pay, they now pay Y plus 43.75. This is how we can break down this equation. The money X minus 4 friends pay minus the money X friends pay must be equals to 43.75. That is to say that 3,500 divided by X minus 4 minus 3,500 divided by X should be equals to 43.75. Let's go ahead and find the value of X. We're going to start by multiplying out by X minus 4. So if we multiply that first term by X minus 4, we're going to be left with only 3,500. And then now we multiply in 3,500 on the middle term with the X minus 4. So if we multiply it by X, we're going to get minus 3,500X. And when we multiply it by minus 4, we're going to get plus 14,000. Everything divided by X. This will be equals to 43.75 multiplied by X. So we're going to have 43.75X. If you multiply it by minus 4, you should get minus 175. We still multiply it out, but this time with X, so that we can cancel out that X on the denominator. 3,500 multiplied by X, that is just 3,500X minus 3,500X plus 14,000. X and X are going to cancel out, so we don't have a denominator anymore. Well, we have a denominator of 1. On the right hand side, we're going to have 43.75x squared minus 175x. 30,500x minus 30,500x, that is 0. If we group the like terms, we're going to get 43.75x squared minus 175x minus 14,000 being equals to 0. If we divide every term by 43.75, we're going to get x squared minus 4x minus 320 being equals to 0. So now we just need to factorize. How are we factorizing this? Which two numbers do we multiply and get minus 320? But when we add them, we get minus 4. That is minus 20 and plus 16. So we're going to have x minus 20, x plus 16 being equals to 0. X is equals to 20 or x is equals to minus 16. Obviously, we cannot have minus 16 people. So our answer here is x is equals to 20. 20 friends want to go on the trip. Let's look at 1.3.2. Calculate the total amount that each friend pays for this trip in order to cover the cost. The cost per person when the 4 friends don't have money to pay is equals to 3,500 divided by x minus 4. We know that x is 20 and we just subtract 4 there. The friends are going to pay 218.75 rands to cover the cost of the trip. The sum to infinity of a geometric series is 6, and the sum to infinity of the squares of the terms of the series is 6. 3.1.1, write down the second term of the series of squares in terms of a and r. The second term of the series will be given by a multiplied by r to the power 2 minus 1. So T2 is equals to a multiplied by r. But we're looking for the second term of the series of squares. All the terms are getting squared. So T2 squared will be equals to AR squared. This is just equals to A squared multiplied by R squared. So this is the second term of the series of squares in terms of A and R. Let's look at 3.1.2. Calculate the values of A and R. This question is for 6 marks, by the way. The sum to infinity of a geometric series is A divided by 1 minus R. We are told that the sum to infinity is 6. So we have 6 being equals to A divided by 1 minus R. We want to find the value of A and the value of R. Let's cross multiply. If we do that, we're going to get A being equals to 6 minus 6R. We have 2 variables, A and R. We need at least another equation. So we can let this be our equation 1. And then another information we are told that the sum to infinity of the squares of the terms of the series is 6. The sum to infinity, let's just put 2 here to show that it is the sum to infinity of the squares of the terms of the series. But what you need to realize is that instead of having A, if we are squaring all the terms, then the first term will be A squared divided by 1 minus. Instead of R, we're going to have R squared. This makes sense if you look at the second term in 3.1.1. I think 3.1.1 is setting us up to be able to answer 3.1.2 to make that realization. We know that the sum is 6 and this is equals to A squared divided by 1 minus R squared. If we cross multiply, we're going to get A squared being equals to 6 minus 6R squared. We can let this be our equation 2. What we want to do here is to substitute equation 1 into equation 2. In place of A, we are replacing it with 6 minus 6R. So we're going to have 6 minus 6r squared being equals to 6 minus 6r squared. So what is 6 minus 6r squared? 6 multiplied by 6, that is 36. 6 multiplied by minus 6r, that is minus 36r. You multiply that by 2, you get minus 72r. And then minus 6r multiplied by minus 6r, we're going to get plus 36r squared. This is equals to 6 minus 6r squared. Let's take 6 to the left hand side. We're going to get 30 minus 72r, and then 36r squared plus 6r squared, that will be plus 42r squared being equals to 0. We can write this nicely and get 42r squared. This is minus 72r and not just minus 72. And then minus 72r plus 30 being equals to 0. If we take a common factor of 6, we're going to get 7r squared minus 12r plus 5 being equals to 0. So now we can go ahead and factorize. Well, factorizing this is extremely difficult, so it is better if you use the quadratic formula. But anyway, we're going to have 7r minus 5 multiplied by r minus 1. So r is equals to 5 divided by 7, or r is equals to 1. Well, r cannot be equals to 1 if our series is converging. That is the value of r. Now we can find the value of a. We know that a is equals to 6 minus 6r. So we're going to have 6 minus 6 multiplied by 5 divided by 7. So the value of a is 12 divided by 7. Let's go ahead and do 3.1.3. Write down T6 of the series of squares. Under normal circumstances, T6 is equals to AR to the power of 5. But we want T6 of the series of squares. So T6 of the series of squares will be equals to AR to the power 5 squared. So we have A to the power 2, R to the power 10, 5 multiplied by 2. So what is A? A is 12 divided by 7. We square that and we multiply by r. What is r? R is 5 divided by 7 to the power 10. This is equals to 0.1. Let's look at this. Let's look at the last question, 3.2. We're not going to waste a lot of time here. There are 50 liters of water in a container. Water evaporates from this container at the rate of 1% per hour under certain weather conditions. How much water will be left in the container after 8 hours if left under these weather conditions? So the amount of water that is going to be left after 8 hours will be equals to 50 multiplied by 99% to the power of 8, which is equals to 46.14. In an hour, we are left with 99% of the water because it is evaporating at a rate of 1% in an hour. But we have 8 hours, hence that 8 is up there. We are left with 46.14 liters of water. Determine the values of P and Q if the asymptotes intersect at x is equals to 1 and y is equals to minus 3. So we are given the equation of f of x. It is said to be equals to a divided by x plus p plus q. In order to find the value of p, we let x plus p be equals to 0. But we already have the value of x. It is equals to 1 at the vertical asymptote. So 1 plus p is equals to 0. It is now easy to see that p is equals to minus 1. The value of q, on the other hand, is just equals to the horizontal asymptote, which is minus 3. P is equals to -1 and Q is equals to -3. So f of x, now at this point, we know that it is equals to a divided by x minus 1 minus 3. In 4.1.2, we're looking for the value of a. How are we going to possibly find that? We're going to substitute the y-intercept or any other point on the graph. So the y-intercept, x is 0 and y is -5. So let's go ahead and substitute that in our graph. We're going to get -5 being equals to a divided by 0 minus 1 minus 3. If we take -3 to the left hand side, we're going to get -2 being equals to a divided by -1. It should be easy to see now that a is equals to 2. So that is 4.1.2. Let's go ahead and do 4.1.3. If f of x is translated to g of x, describe the translation from g to x. So let's go ahead and take a look at this. In f of x, we have x minus 1. In g of x, we have x minus 3. So when it comes to the x values, x minus shifts the graph to the right and x plus shifts the graph to the left. We had x minus 1. On g of x, we have x minus 1 minus 2, which is just x minus 3. So we have moved 2 units to the right. We can go ahead and write it down as moving 2 units to the right. On f of x, we have -3. On g of x, we have +3. From -3 to +3, you need to add 6. So we have shifted our graph 6 units up. So here we're going to have 6 units up. 4.1.4, write down the equation of the horizontal asymptote of G. The horizontal asymptote is this value here all the time. So for 4.1.4, we can easily say that y is equals to 3. We are supposed to show that f of x is equals to x squared plus 6x plus 5. What information are we given? We're given the intercepts of f of x, which is p and t. So finding f of x should be relatively easy if we have the intercepts. We can just say that f of x is equals to a multiplied by x minus x1 multiplied by x minus x2. In place of x1 and x2, we are substituting the x-intercepts. So f of x is going to be equals to a multiplied by x plus 5 multiplied by x plus 1. So f of x is equals to a multiplied by x, that is x squared, and then plus x plus 5x plus 5. So we have f of x being equals to a multiplied by x squared plus 6x plus 5. We just need to substitute any point on a graph except from the x-intercepts to find the value of a. We can substitute w, which is our y-intercept. If we do that, we're going to have 5 being equals to a multiplied by 0 squared plus 6 multiplied by 0 plus 5. 5 is going to be equals to a multiplied by 5. It will be easy to see now that a is equals to 1. So f of x is just equals to x squared plus 6x plus 5. That is 5.1. Let's look at 5.2. In 5.2, we're supposed to calculate the coordinates of Q. So let's look at P and Q. At P, our two functions, f of x and g of x, they intersect. The same is true at Q. The two functions intersect. So in order for us to find the value of Q, we need to equate these two functions. So we can say that f of x is equals to g of x. If we do this, we're going to be able to find the x value of P and the x value of Q. We already know the x value of P. It is -5. So we're just going to find the x value of q. F of x, that is x squared plus 6x plus 5. G of x is 2x plus 10. So let's take 2x to the left-hand side together with 10. We're going to get x squared plus 4x minus 5 is equals to 0. So we just need to factorize this. Which two numbers do we multiply and get minus 5? But when we add them, we get 4. That is 5 and minus 1. So we're going to have x plus 5 multiplied by x minus 1 being equals to 0. So x is equals to minus 5 or x is equals to 1. But we know that at x is equals to minus 5, this is where we have the x coordinate of p. So x is equals to 1 must be the x coordinate of q. So now we just need to substitute x is equals to 1 in either f of x or g of x to find the y value of q. So let's substitute it into g of x. So g of 1 will be equals to 2 multiplied by 1 plus 10, which is equals to 12. So the coordinates of q, we have 1 as our x value and 12 as our y value. That is how we're supposed to answer that question. Now we're supposed to show that in 5.3, we're supposed to show that f of x is not equals to minus 5 for all values of x. Let's try showing that it is actually equals to minus 5. And in failing to show that it is equals to minus 5, we would have sort of proved that it is not equals to minus 5. So 5.3 f of x is equals to minus 5, right? So what is f of x? That is x squared plus 6x plus 5 being equals to minus 5. So we're going to have x squared plus 6x plus 10 being equals to 0. In order to factorize this, we need the aid of the quadratic formula. So x is equals to minus b plus or minus square root of b squared minus 4ac, everything divided by 2a. So there's no way issues are going to arise with 2a or minus b. What we need to focus on is square root of b squared minus 4ac. If that number is negative and we cannot take the square root of a negative number, then it would simply imply that f of x can never be equals to minus 5. So let's go ahead and compute that. So the square root of b squared, what is b? B is 6 in our instance, right? So 6 squared, that is 36 minus 4ac. A is 1, c is 10, so minus 40 essentially. As you can see now, we have square root of minus 4, and we cannot compute square root of minus 4. So f of x can never be equals to minus 5. Now we know for sure. Let's move to the following question. 5.4. Consider point R when SR is at its maximum in the interval x is between x at p and x at q. And then let's do the following. 5.4.1. The gradient of the tangent to f at r. The gradient of the tangent to f at r. So let's look at this statement, this opening statement, and see if it can help us to find the gradient of the tangent to f at r. So let's consider point r. Point r is right here. And then when SR is at its maximum in the interval x is between x of p and somewhere here x of q, and determine the gradient of the tangent to f at r. So they're saying that SR is a maximum. It is the maximum distance between x of p and x of q. So what we can actually do, we can find an equation for the distance between the two graphs. The graph that is above is g of x, right? And the graph below is f of x. So we can say g of x minus f of x. And we're going to have an equation for the distance here. After finding the equation for that distance, we can derivate it and equate to 0 in order to find the x value for which it is a maximum, and that will be the x value at r. So that will look something like the following. So we're going to have the distance being equals to g of x minus f of x. G of x, that is 2x plus 10, minus f of x, which is x squared, plus 6x plus 5. So we're going to have 2x minus 6x. So we have minus 4x, and then 10 minus 5 plus 5 minus x squared. This is our distance. Now let's go ahead and derivate. If we do that, we're going to have minus 4 minus 2x. And then we are equating to 0 in order to find the x value for which that distance is a maximum, which will be the x value of r and the x value of s. If we take minus 4 to the other side, we're going to get 4 is equals to minus 2x. We divide both sides by minus 2, we get minus 2 is equals to x. So this is the x value at point r, and we want the tangent at r. So if we have the x value, what we can do is derivate f of x and then equate that x value. In derivating f of x, we're going to get 2x plus 6. When we substitute minus 2, we're going to get 2 multiplied by minus 2 plus 6. This will give you 2. So the gradient at r when x is equals to minus 2 is 2. We have answered the first question. Now let's go ahead and answer the question that follows. It is saying, let's find the equation of the tangent to f at r. So the equation of a tangent, it is a straight line. We're going to have y is equals to mx plus c. M is the gradient, so y is equals to 2x plus c. We need to substitute point r into this equation so that we can find the value of c. For point r, we have x of r, which is equals to minus 2. So we can say f of minus 2 in order to find the y value at r. So we're going to have minus 2 squared plus 6x, not 6x, but 6 multiplied by minus 2 plus 5. So minus 2 squared, that is 4, 6 multiplied by minus 2, minus 12. So we have minus 8 plus 5, which will be minus 3. The coordinates of r, we have minus 2 and minus 3. So if we equate it into our equation, we're going to get minus 3 being equals to 2 multiplied by minus 2 plus c. So minus 3 is equals to minus 4 plus c. So 1 is equals to c. Then y will be equals to, what is the gradient? 2. So we're going to have 2x plus 1 being the equation of our tangent. The last question, 5.5. Consider x being greater than x at p, and then for which values of x is g of x minus the inverse greater than 15. Right, so g of x is equals to 2x plus 10. Let's see if we can find g inverse. So in order to find g inverse, we need to swap x and y and solve for y. If we do that, we're going to have something like the following: 2y plus 10. So 2y is equals to x minus 10. So y is equals to a half x minus 5. This is g inverse. So now we're looking for g of x minus g inverse being greater than 15. So let's go ahead and substitute. We're going to have 2x plus 10 minus a half x minus 5 being greater than 15. So 2x minus a half x, that will be 3 divided by 2x, and then 10 minus 15, that will be plus 15 being greater than 15. So we can take 15 to the right hand side. we're going to have 3 divided by 2x being greater than 0. 15 minus 15 is 0. So if we divide both sides by 3 divided by 2, then our answer is yes, x is greater than 0. F of x is said to be equals to 4x squared minus x. If we use the power rule, f prime of x is equals to 8x minus 1. So in using the first principle, if we don't get to 8x minus 1, then we made a mistake somewhere. So let's go ahead and derivate this function using first principles. First, we're going to compute f of x plus h. We are replacing x with x plus h on our equation f of x. We're going to get 4 multiplied by x plus h squared minus x plus h. If we solve this, we're going to get 4 multiplied by x plus h squared. That is x squared plus 2xh plus h squared minus x minus h. This will be equals to 4x squared plus 8xh plus 4h squared minus x minus h. We have f of x plus h. Let's go ahead and subtract f of x. So f of x plus h minus f of x will be equals to 4x squared plus 8xh plus 4h squared minus x minus h. Everything minus 4x squared minus x. So we have 4x squared minus 4x squared. That is 0. And then we have minus x plus x. That is also 0. So f of x plus h minus f of x will give us 8xh plus 4h squared minus h. Now we just need to divide by h. So we're going to have f prime of x being equals to the limit as h tends to 0 of 8xh plus 4h squared minus h divided by h. We can take h as a common factor on the numerator. We're going to have the limit as h tends to 0 of h multiplied by 8x plus 4h minus 1. Everything divided by h. H and h cancels out, and then now we are letting h tend to 0. So we're going to have 8x minus 1. The same answer we got when we used the power rule. Let's look at 7.2. 7.2.1. Determine dy dx if y is equals to, so we have y being equals to minus x to the power 3 minus 16x squared plus 6x. dy dx will be equals to minus 3x squared minus 32x plus 6. And just like that, we have answered 7.2.1. No trickery whatsoever. Let's do the equation that follows. 7.2.2. This one is a bit interesting. F of x is equals to 4 divided by 5x to the minus 3 divided by the square root of x squared. Well, the cube root of x squared. Let's write f of x in our usual format. We're going to get f of x being equals to 4 divided by 5 x to the power 3. If it is x to the power minus 3 and it is on the denominator, when you put it on the numerator, it's going to be x to the power of 3. We have the cube root of x squared. This is just equals to x to the power 2 divided by 3. So we're going to have x to the minus 2 divided by 3. Now we have our equation in our usual format. We can go ahead and use the power rule. So we're going to have 3 multiplied by 4 divided by 5, x to the power 3 minus 1. minus 3 multiplied by minus 2 divided by 3, x to the minus 2 divided by 3 minus 1. This is equals to 12 divided by 5, x to the power 2 plus 2x to the power minus 5 divided by 3. We're supposed to sketch a cubic function given these following properties. The first property is that f of minus 2 is equals to f of 1 is equals to 0. So if f of minus 2 is equals to 0, when x is equals to minus 2, we have our x-intercept. So let's go ahead and put that in our graph. So here at minus 2, and here at x is equals to 1, we have our intercepts. The next property is that f prime of 1 is equals to f prime of minus 1 is equals to 0. So at x is equals to 1 and x is equals to minus 1, the gradient is 0. Here at x is equals to 1, we have an intercept and turning point at the same time. Right, and then f of minus 1 is equals to 4. So we have a coordinate here. F of minus 1 is equals to 4. And then f of 0 is equals to 2. That is our y-intercept. So f of 0 is equals to 2. The gradient of our graph is less than 0 when x is between minus 1 and 1. Let's try connecting these points and see what we have. So here at x is equals to minus 1 and 4, we have a turning point. And then the same is true with x is equals to 1. We have a turning point right here. So we're going to have something that looks like this. Let's answer the following question. 8.2. Determine the equation of f in the form y is equals to. Because we have the x-intercepts of our function, it will be easy to determine the equation. F of x is equals to a multiplied by x minus x1 multiplied by x minus x2 squared. So why do we have x minus x2 squared here? We squared the intercepts that also serves as a turning point. So when we substitute here, we should have f of x being equals to a multiplied by x plus 2 multiplied by x minus 1 squared. This is what we need to solve. So f of x is equals to a multiplied by x plus 2. X minus 1 squared, that will give us x squared minus 2x plus 1. So f of x is equals to a multiplied by x to the power 3 minus 2x squared plus x plus 2x squared minus 4x plus 2. If we solve that, we're going to get f of x being equals to a multiplied by x to the power 3 minus 2x squared plus 2x squared. So that is 0. X minus 4x, that is minus 3x plus 2. This is our equation. We just need to find the value of a. How can we possibly do that? We can substitute a coordinate into this equation. We know that f of 0 is 2 from our properties. So we can say that 2 is equals to a multiplied by 0 to the power 3 minus 3 multiplied by 0 plus 2. So 2 is equals to a multiplied by 2. It should be easy to see that a is equals to 1. So if we substitute 1 back here, then we're going to get f of x being equals to x to the power 3 minus 3x plus 2. This is our equation. Let's move to the following equation. 8.3. If g of x is equals to f of x minus 3, write down the x-intercepts of g. Right, before we break down this equation, let's write down the x-intercepts of f of x first. We have minus 2 and 0. We also have 1 and 0. Now let's make sense of this transformation. g of x is equals to f of x minus 3. So x minus 3 shifts the graph of f of x 3 units to the right. If it was plus, then it would shift it to the left. It is counterintuitive, but it is what it is. So we just need to move these x values 3 units to the right to get the x-intercepts of g of x. So minus 2 plus 3, that is 1, and we have 0 as our y value. And then 1 plus 3, that is 4, and we still have 0 as our y value. So this is the intercepts of g. If you instead substitute x minus 3 in place of x in f of x, you will probably get to the same answer, but that will take the entire day. So it is easier to do it like this. Let's look at 8.4. Determine the values of p for which x to the power 3 minus 3x plus 2 is equals to p will have exactly one root. Exactly one root means exactly one x-intercept. So if we write this nicely, we're going to get x to the power 3 minus 3x plus 2 minus p is equals to 0. So minus p is shifting our graph up and down. P is greater than 4 or p is less than 0. If you want to know how this comes about, then click this video on your screen right now. Show that the total area of the square and the circle formed is given by this equation. A boy uses 12 meters of wire to form a circle and a square. Each side of the square is x meters long. So on each side of the square, we're supposed to have x meters. So we're going to have something that looks like this. So the amount of wire used to make the square is 4x, as each side is x meters long. Amount of wire used to make the circle will be 12, the total amount of wire, minus the amount of wire that was used to make the square, which is 4x. The wire used for the square and the wire used for the circle. As soon as you miss this, there's no way you can answer this problem. You need to realize that this is the case. So for the area of the square, we're going to have the area being equals to x squared. And then now comes to the area of the circle. The amount of wire used for the circle is 12 minus 4x. This is the circumference of our circle. It is 12 minus 4x. So we can say that 2 pi r is equals to 12 minus 4x. 2 pi r is the formula you use to get the circumference. In this case, it is equals to 12 minus 4x. We want to find the area of the circle. So I'm doing this so that I can find the radius, because as soon as I have a radius, I have an area for that circle. If I divide both sides by 2 pi, I'm going to get r being equals to 12 minus 4x divided by 2 pi. I think I can factor out 2 here on the radius. If I do that, I'm going to get 6 minus 2x divided by pi. I took a 2 as a common factor on the numerator and then on the denominator, and I cancelled out. So the radius is 6 minus 2x divided by pi. Now we can go ahead and find the area of our circle. So the area of the circle will be pi r squared. So we're going to have pi multiplied by the radius, which is 6 minus 2x divided by pi squared. This will be equals to pi multiplied by, so 6 minus 2x squared, 6 multiplied by 6, that is 36. 6 multiplied by minus 2x, that is minus 12x. You multiply that by 2, you get minus 24x. And then minus 2x multiplied by minus 2x, we're going to get plus 4x squared. Everything divided by pi squared. We can cancel out pi and pi. So we're going to get 4x squared minus 24x plus 36 divided by pi pi. This is the area of the circle, and this is the area of the square. We want to find the total area, so we can just easily add those two. We're going to have the area being equals to x squared plus 4x squared minus 24x plus 36 divided by pi. So I can rearrange this and get pi x squared plus 4x squared minus 24x plus 36, everything divided by pi. I have x squared and x squared, which I can take as a common factor of those two terms and get the area being equals to 4 plus pi multiplied by x squared minus 24x plus 36, everything divided by pi. And this is what I'm required to prove. The total area of the square and the circle formed. 9.1. Let's move to 9.2. Determine the value of x for which the total area is minimum. So the area is equals to 4 plus pi x squared minus 24x plus 36, everything divided by pi. We need the value of x for which this area is a minimum. So we need to derivate at some point. It looks like it will be very difficult to derivate, but it is actually not. Let me show you how. Let's give every term on the numerator its own base of pi. So if we do that, we're going to get 4 plus pi multiplied by x squared divided by pi minus 24x divided by pi plus 36 divided by pi. So we want to derivate and equate to 0. Here we just simply apply in the power rule. So we're going to have 2 multiplied by 4 plus pi divided by pi x minus 24 divided by pi. 36 divided by pi is a constant. So this will be equals to 0. So now we can say that x is equals to 24 divided by pi with everything divided by 2 multiplied by 4 plus pi divided by pi. The value of x for which the area will be a minimum is 1.68 meters. How many 4-digit codes will be formed using these digits? With the following conditions. The code must be an even number. The first digit must be less than 4 and the digits may be repeated. 4-digit codes, so we have 4 spaces that we need to fill. The code must be an even number, so on the last position we need an even number. If the number on the last position is even, then the code itself is even. So how many even numbers do we have here? We have 0, 2, and 4. So only 0, 2, and 4 can occupy that last spot. The first digit must be less than 4. If it is less than 4, then only 0, 1, 2, 3 can occupy that first spot. We need to put that in mind. So in the first position, one of the 4 digits can occupy that spot. And then on the last position, one of the 3 digits can occupy that spot. What about the second and the third spots? 1, 2, 3, 4, 5, 6, 7. So we're going to have 7 here, and we're also going to have 7 here if repetition is allowed. The answer here is 588. So this is the number of digits that we can generate using those digits and having those conditions. The answer to 10.2. Let's look at 10.3. The letters of the word leopard are randomly arranged into different 7 letters words. Letters may not be repeated. And then the first question, 10.3.1, in how many different ways can the letters of this word be arranged? So let's go ahead and look at our word. We have 1, 2, 3, 4, 5, 6, 7 letters. In how many ways can we arrange 7 letters? All the letters are distinct. There's no repetition on the letters. So the answer here is 7 factorials because there is no repetition. If there was a repetition, then we would have to account for that. And then the following question, 10.3.2, determine the number of different ways in which a word formed will start with a vowel and end with a consonant. Right, let's see how that will look like. We need 7 spaces as we have 7 letters. So we're going to have 1, 2, 3, 4, 5, 6, 7. We need to start with a vowel. How many vowels do we have on the word leopard? We have E, O, and A. So we have E, O, and A. And then the other condition is that it ends with a consonant. And then our consonants here is L, P, R, D. The first position is going to be occupied by one of the 3 vowels. So we're going to put 3 here. And then the last position is going to be occupied by one of the 4 consonants. So we're going to put 4 here. We started with 7 letters. Now we have used 2. One to occupy the first spot and another one to occupy the last spot. We are left with 5. So we're going to have multiplied by 5. Now we are left with 4, 3, 2, and then 1. This is all equals to 1,440. The last question, which is a bit tricky, 10.3.3. Calculate the probability that in the different words formed in 10.3.1, all vowels will not follow each other. It's very difficult to count will not compared to counting will. The probability of an event not occurring is equals to 1 minus the probability of that event occurring. So what we can do instead, we can calculate the probability of the vowels following each other. And then the probability of the vowels not following each other will be 1 minus the probability of the vowels following each other. So let's go ahead and do that. We have 1, 2, 3, 4, 5, 6, 7 spaces that we need to fill. Let's say that our vowels follow each other. So we have A, E, and O. And then the consonants L, P, R, D. So if the vowels are following each other, then we can sort of bind them together, so to say. Wherever they are, they need to be close to each other. Even though the vowels are next to each other, there's still 3 factorial ways of arranging them. We can start with E, we can start with O, so on and so on. So we're going to have 3 factorial. This is for the arrangement of the vowels among themselves. They're still close to each other. So now we have vowels that are moving as one, and we have 4 consonants. The vowels can be in between 2 consonants. There is no problem as long as the vowels are close to each other. So there is 5 factorial ways consonants and the 3 vowels that needs to be next to each other can be arranged. This is equals to 720. So the probability of the vowels not being close to each other will be 1 minus the probability of the vowels following each other. This will be 720 divided by our sample space, which is 7 factorial.